instance. You are managing a complex infrastructure, okay, with multiple components. Means that the code that you are writing in the Terraform file have the multiple components, and you need to ensure that the Terraform deploy all the resources in the correct order. So this is the key point here. The resources needs to deploy in a correct order. What steps you take to accomplish this? So as you now know that the Terraform has a built-in dependency management system. That system ensures resources are deployed in a correct order. To make sure that the Terraform deploy all the resources in the correct order, you can use the depends on argument. Depends on argument, okay. If you have any difficulties in understanding the depends on argument, you can refer the I button which is coming at the top of this video. Okay, so depends on argument in your resource block you have to use. Okay, this argument specify the order in which Terraform should create the resources. Let's take an example. If you have a virtual machines that depends on the network interface, okay, you can use the depends on argument to make sure that the network interface is created before the virtual machine. Okay, so in that case, how you will write a code? In that case, you will write a code like, suppose resources for the AWS network interface okay, and then you provide some local name here like example, okay, and then you put all the code for the network interface. So this is the network interface that you want to deploy first before creating the AWS instance, you can say. And now in the resource of AWS instance, call my EC2. This is the local name that I am assigning. Here you can just do a linking like network interface ID is equal to AWS underscore network underscore interface and whatever is your local name, this one, dot example dot ID. So this will create a linking that this particular interface is linked with AWS instance is linked with the AWS network interface. Now you have to write the depends on. And here you have to write AWS network interface dot example. Okay, then you have to close it. So in this example, the AWS instance resource depends on the network interface resources. Terraform will create the network interface first. So this will be created first because we have the depends on the AWS instance. When the AWS instance get created, it's first check that either the network interface created or not. So it will first create the network interface, then do the linking because of this attributes. Okay, so hope it's clear. So these types of questions will definitely you can encounter in the interview, and you have to tackle in this way. Okay. Question. You need to create a multiple instance. So this is the main keyword here, of the same resources with slightly different configurations. Okay, slightly different configurations. How can you accomplish this efficiently in Terraform? So if you remember my previous session on the Terraform, so you can understand these questions, that Terraform allow you to use loop to create multiple instances of the same resources with slightly different configurations. To do this, which meta argument we can use? We can use the count meta argument in your resource block, which specify how many instances of the resources to create. If you didn't refer my previous video on the count meta argument, you can find the I button which is appearing at the top of this particular video. You can refer for more details. How we can use the meta argument? When you create any resources with, for suppose example, I am creating the AWS instance, AWS underscore instance, and the local example my EC2. Okay, then here you can use the count. Suppose I want to create 3 resources of AWS instance. Okay, for that I just provide the count is equal to 3, the AMI, which you can keep in the variable, or you can hard code as well, AMI with some numeric values. Okay, and the instance type, as per your requirement. Suppose I am taking t2.micro. Okay, and here you can use the tags. Okay, and in the tag you have the name that we are going to define for the instance. Here you can use the count, like example, you can consider it example. This will come for the each of the instance, but this is the field that is coming dynamically. Okay, count dot index. And then close it and close the main one. Okay, so in this example, Terraform will create 3 instances of the AWS instance resources, and each with a different name. So what will be the name of the instance that will get created? Example 0, because we are using the index count dot index which start from 0. Okay, second will be example 1, third example 2. So in this type you can see that we can understand the questions and give the proper explanations for that particular questions with some example. Okay, that says you want to create an EC2 instance using Terraform and then execute a shell script on the instance after it has been created. How can you achieve this? So in the Terraform, you can use the remote exec provisioner to execute a script on a newly created EC2 instance. So we are going to execute the remote exec provisioner. So if you are not familiar with this provisioner, we discussed all the provisioner including the remote exec in more detail in my Terraform tutorials. So you can refer that particular session for more details on the provisioner concepts. You can find the link that is coming at the top of this video. You can refer for more details. The steps that you can take to create an EC2 instance using Terraform and then execute the shell script on the instance. So first you need to create an EC2 instance, and after that we will execute the remote exec provisioner, and in that provisioner we will write some shell script. Okay, so for example, we are going to use the Terraform configurations to create an EC2 instance. For that you can write the resource, okay, and you can use the AWS instance, and you can provide any of the name, like I am providing the example. Okay, and here you have to provide all the informations what we are going to use, like AMI. You can provide the AMI informations, the instance type that you can use. If you want to execute it in the free tier, you can use the T2 micro, okay, or T2 small for some cost associated with it. You can provide the subnet ID, VPC security, okay, VPC security group ID. So VPC security groups ID, and here you can provide the ID. You can provide the key name as well, because you have to SSH what key name you have in that particular region, like AWS underscore key pair. Okay, for example, I am using the key name, and the tag, that is optional. Okay, you can use that as well. So you can understand why this instance got created, and this instance is used for which purpose. I am using example. So this will help you to create the EC2 instance, okay, and use the remote exec provisioner to execute a shell script. So after the EC2 instance has been created, you can use the remote exec provisioner to execute a shell script on that particular instance. For example, you can use the description that I am providing you for the remote exec provisioner, that will configure to execute a shell script and install the Apache web server on the instance. Okay, we already executed these types of command in my Terraform tutorial video. You can refer that as well. Okay, so for that you have the instance created. Now you can use the provisioner. Which type of provisioner is a remote exec? Okay, and you will write some inline command here. That is the command which executed when the instance get up. Okay, so which type of command we are going to use? We are giving the sudo and yum update. First we are going to update the machine, okay, with confirmation flag of y, and then we are going to execute install sudo yum install with a confirmation flag httpd. Okay, and then you have to start it. systemctl start httpd. Okay, and after that you have to enable it, because we are going to enable it, because if for any reason the instance get down, then after it get started, then the Apache web server will start automatically. Okay, systemctl enable httpd. Okay, these are the inline command which executed, and these all goes into this way. So in this example, the remote exec provisioner, this one, okay, is used to execute a series of shell commands on the newly created EC2 instance. The inline command, or you can say the inline parameter, is used to specify the shell command to be executed. So in this case, the shell commands update the instance, install the Apache web server, and start the web server, and enable the web server to start automatically when the instance boots. Okay, so you can create a EC2 instance using Terraform and then execute a shell script on the instance, which allow you to automate the setup and configure your instance. So this fulfill the answer of this particular scenario based question on the Terraform, and you will encounter these types of questions will get asked in the interview when which is related with the Terraforms. So hope you like. Okay. So in this particular scenario based questions, you want to create a Terraform modules that can be reused across multiple projects. Okay, so this is the advantage of Terraform modules, that we can reuse it across multiple projects, but you need to parameterize certain value so that they can be customized for each project. How can you accomplish this in a Terraform? So whenever the concern regarding the Terraform modules, this is used to change the certain value for the parameters. Okay, some parameters value we set it as a default. Okay, so that if it is not passed, the default will be value will be picked. Okay, so before proceeding, what is the Terraform module exactly? So a Terraform module is a set of Terraform configuration file in a single directory. So we keep some tf.tf file, which is the extensions of the Terraforms, into a directory, and we call it as a module. Suppose you created a modules for the EC2 instance, you just call that particular modules and the source where the module is located, and use to create a EC2 instance. So you don't have to configure each of the things, like which instance type you want to use for which reasons. Okay, so things needs to be passed as a default value which is required, and if you want to change it, you can parameterize it. So this is the things we are going to look into this particular sessions. So Terraform allow you to create a parameterized modules using the input variables. Okay, so input variable allow you to pass the value into a modules from the calling code. To create a parameterized modules, you can define input variables in your modules using the variable block. So when you create a modules, you define a variable. Okay, you define a variable and you define it for the reason. Okay, in this particular block, you define the type, you restricting it to use it for a type like a string, s will be small. Okay, and the default you are providing here. Okay, this is very means good steps to always provide the default value. Otherwise, it will ask you to provide at the runtime. Okay, and the resource sections you define for the AWS instance. Okay, my name it as a local my EC2, and here you define the AMI. Okay, here you have the AMI value, the alphanumeric character, the instance type, suppose I am providing T2 micro, and the reason I am providing var. Here I am taking it from the variable here, from here. Okay, var dot reason. Okay, and now close it. So in this case you can see that my EC2 instance, the AWS instance resource is parameterized by the reason input variables. When you call this module from another Terraform configurations, because this is, you are creating a module that you can reuse or you can reuse in different projects. So you can pass it in a different value for the reasons. Okay, suppose you don't want to create in US East 1, but you want to create in US West 2, but you want to use this particular module and pass the parameter for the reason. So how you can do that? So simply you just need to use the module in your different projects, or you can say in the same project if you're creating the instance using this particular modules. Okay, here you define the source. This is the path of the directory. In my case, we have in the similar projects my EC2, and the reason we are providing here US West 2. Okay, so in that case, let me close it. In this example, the my EC2 module is called with a value of US West 2 for the reason input variable. Okay, we are passing the reason as an input variable, where we are going to create these particular modules that we created earlier for different reasons. We are now going to deploy the EC2 instance in this region. Okay, this allow you to reuse the same module across multiple projects with different configurations. So I hope these explanations in understanding the modules are very sure. Questions. You have a Terraform configurations that creates multiple resources in a specific order. So in the Terraform you can write or you can create multiple resources. Okay, and that resources we needs to deploy in a specific order, but you need to skip a specific resource in the sequence. So you don't need to deploy a specific resources, you have to eliminate it. How you can accomplish this in Terraform? So the Terraform allow you to skip a specific resources in the resources by using the -target flag. You have to apply it. This is the options with the Terraform apply command. The -target options allow you to specify a specific resources to create or update while skipping all the other resources. Let's take an example. Suppose you have a Terraform configurations that create 3 resources in an order: a network interface, a security groups, and an EC2 instance. If you want to skip the security group and only create the network interface and EC2 instance, then you have to write a command in this way. Terraform apply, okay, and then you have to put the target options. Okay, in that case you will write here the AWS underscore network underscore interface. And whatever the internal name, in my case, suppose example, this is the internal name we taken. Okay, so we will use this particular resources to be created, and the target again, and this is equal to AWS underscore instance. Okay, and again example, this is also again a internal name. So in this example, the dash target options, okay, is used to specify the AWS network underscore interface dot example and AWS instance dot example resources, while skipping the AWS security groups. So it will not get created. Terraform will create the network interface first and then create the EC2 instance without creating the security group. It is also important to note that using the dash target options can cause issues with the resources dependency and can potentially create an inconsistent state also. Therefore, it is generally recommended to avoid using the dash target options and instead modify your Terraform configurations to explicitly define the order of creations and dependency between the resources. So how we can do that? So in this example, you can modify your Terraform configurations to define the dependency between the security groups and the EC2 instance, and use the depends on parameters, this one, to specify the order of the creations. So you create the AWS security groups, AWS interface, but the AWS instance have the dependent on these two resources. This needs to be created first, then the AWS instance will be created. Okay, so by using the depends on parameters, the Terraform will create the security group first, and then the network interface, and finally the EC2 instance, ensuring that the resources are created in the correct order. That dependency in a respected way. So in conclusion, we can say that while the target options can be useful in certain scenarios, it is generally recommended to avoid using it and instead modify your Terraform configurations to explicitly define resources dependency and creations order. This ensures that your infrastructure is created and updated in a consistent and a predictable manner. So what is your expectations? It will perform those steps only. Terraform. You want to deploy a Terraform configurations that creates an EC2 instance in a specific availability zone, but you are not sure which availability zone to use. How can you dynamically select an availability zone at runtime in Terraform? So if you know that which availability zone to use at the time of creations of the instance, you can define that particular availability zones, or you can define in a variable and use under the availability zones parameters while creating the AWS instance, but you have to dynamically select it. So in the case of dynamically selections, you have to identify which availability zones in a particular region is available. Okay, so in Terraform you can use the data resources to retrieve informations about the availability zones in your AWS region, whichever you are using. Whichever AWS region you are using, you have to use the data resources to retrieve that informations. Then use the random provider to select a random availability zones from the list. Okay, let's see the steps we can take to dynamically select an availability zones at the runtime in the Terraform. Okay, so the first steps we can say that we need to retrieve the informations about the availability zones. For that we are going to use the data resources, and this will retrieve informations about the availability zone in your specific AWS regions. So you can use the Terraform configurations, okay, to list all the availability zones. Okay, so for this you have to write the data. Okay, this is the data resources for the AWS availability zones and available with a blank. Okay, this will list you all the availability zones. Okay, so these configurations will retrieves a list of all the availability zones in your AWS region. Now it's time to select the random availability zones using the random provider to select a random availability zones from the list retrieve in these particular steps. Suppose this is the step 1, then you have to retrieve from the step 1. For example, you can use the following configurations, this one, to retrieve the following configurations to select the random availability zones. You can define the resources and you can use the local variable as AWS for the random shuffle. And here you can see that we are picking from the data dot availability zones, which is defined here. Okay, and then available, this is the local name, and then the names. It will list all the names of the availability zones. Okay, once you perform this, you have to store it in a variables, this one. Okay, so you can define a variable where you are taking from the random shuffle dot AWS and the result 0. Whatever is coming first, you have to store it. Okay, so this configuration is used the random shuffle provider to shuffle the list of available zones retrieve from the steps 1. Okay, and then select the first item in the shuffled list as a randomly selected availability zone. Now you have to use the selected availability zone in your Terraform configurations where you are going to create the AWS instance. Okay, so you need to modify your Terraform configurations to use the selected availability zones. Okay, whatever the name you provided, like AG here, it will have the informations about the which availability zone to use for a particular reason. Okay, for example, you can modify your Terraform configurations to create the EC2 instance in the randomly selected availability zones. This is the example. Okay, so you can see that the resources, we are using the resources AWS instance, and this is the local name. We are using example here. We are providing the AMI, which is coming from the variable. Okay, and this already you know that we define the AMI ID. Either it's coming for dynamically or you are doing the hard coded. Okay, if you didn't know about the dynamically association of the AMI ID for a particular reason, then you can refer my Terraform playlist on that. Instance type, we can again taking from the variable, key name from the variable, subnet ID from the variable, associated public IP address. Yes, we want to use it. That's why we put a flag of true. And the availability zone, now it's coming from coming from the variable, which is taking the first item from the list dynamically. Okay, so the availability zones parameters, these parameters, okay, is set to the value of the AG variable, whatever it's get assigned. Okay, which is dynamically selected at the runtime using the random provider. Okay, random shuffle. By following these all steps, you can dynamically select the availability zone at runtime in Terraform, which makes your Terraform configuration more flexible and also adaptable to changing the requirements if it's coming in the future. So this solves this particular interview questions on the Terraforms, that how can we select the availability zone dynamically for a particular reason. You have a Terraform configurations that provisions an EC2 instance, security groups, and key pair. You want to add a new EBS volume to the EC2 instance. how would you go about doing this? So this question is asking you to create an EBS volume and attach with the existing EC2 instance that is managed by the Terraform. So that instance of the EC2 is created by the Terraform itself. Okay, so to add a new EBS volume to an existing EC2 instance that is managed by the Terraform, you have to follow a certain steps. You need to define a new EBS volume resources. So in the Terraform configuration file, you define a new EBS volume resources using the EBS volume, EBS underscore, or you can say the AWS underscore EBS underscore volume resource type. This is the correct name. So for example, you can define the resource. Okay, the resource name should be AWS underscore volume. Okay, EBS underscore volume. The local name, whatever you want to use it, you can. In my case, my underscore EBS. The availability zone, I am defining it, and the size is 20 GB. The size is 20 GB, and the tag we are providing the name of the EBS which we want to just give us a name to that particular EBS volume. So using this code, our new EBS volume is defined with the size 20 GB, and the tag name is my underscore web underscore EBS. Now it's time to attach this EBS volume to the EC2 instance. So for that, we are going to use the resource AWS underscore volume underscore attach. Below a snippet of code you can refer. So resource we are defining AWS volume underscore attach EBS attach. Okay. So the device name we are using the dev under slash SDF, and here we have to provide the volume. Okay, so volume detail, how we can get it? We can get it from here. Okay, we can get it from using the AWS underscore EBS volume dot under my underscore EBS and ID. Okay, and the AWS instance you already created, and that is managed by the Terraform itself. So this is the resource name and AWS underscore instance, and this is the local name we provided at the time of creation of the AWS instance, and this is the ID. So we are just mapping it. Okay, so in this example, the EBS volume is attached to the EC2 instance, and this is the ID we are providing using the device name. Okay, now it's time to apply the changes. After defining the EBS volume and attaching it to the EC2 instance, apply your Terraform changes with the Terraform apply command. This will provision a new EBS volume and it will attach to the EC2 instance. So you have the existing EC2 instance. Okay, this is managed by the Terraform, and EBS volume that you created, okay, you are attaching it. Okay, and this is managed by the Terraform. So these are the steps through which you can add a new EBS volume to the existing EC2 instance, and that is managed by the Terraform itself. This allows you to automate your infrastructure management and ensure consistency and reliability across your applications. Okay, so in future, if you want to just remove the mapping, you just need to modify your configurations of the mapping of the EC2 instance with the EBS volume. Hope you have an applications that requires an AWS RDS instance, and you want to manage its life cycle using Terraform. What steps would you take to achieve this? So after looking these questions, you think about there will be some twist, but this types of question is very simple. How can we manage a resource that is created by the Terraform? Terraform itself manages that resource. If any of the resource that is managed or created, in simple word you can say created, using the Terraform files, that is managed by the Terraform, and we can manage the life cycle of that particular resources. So if you encountered these types of questions in interview, then there will be a very straight answer for this, that a Terraform manage the life cycle of any resource if that resource is created by Terraform itself. So this question is simply asking you, how can you create a RDS instance using the Terraform? Okay, so to manage the AWS instance lifecycle using the Terraform, you can use the AWS-DB-instance resources to create, or if you want to modify, you have to do the changes in the Terraform file, or if you want to delete that particular RDS instance, you have to apply the Terraform destroy command. Define the RDS instance, use the AWS DB instance. Okay, so in this screen you can refer the resource AWS underscore DB underscore instance, and here we have the local name my RDS. We are defining the allocated storage, the engine MySQL, the version of the engine that we are using, and which type of instance class we are using for creations of the MySQL RDS instance, and what will be the name of that particular DB that you created, the RDS instance, and the credential, okay, and the parameter group in which this particular instance belongs to, and the storage type, and what is the name. This is for your internal purpose, that what will be the name, tag name that you are going to use for the RDS instance. So you can see that in this example, the AWS underscore DB instance resources is used to create the MySQL database instance with a 20 GB storage volume, and a db.t2.micro instance class, and a set of default MySQL 5.7 parameters. The name, username or the password parameter are used to specify the name and the login credential of the database. So manage the RDS instance lifecycle. You just need to use the command Terraform apply to create the RDS instance. After the instance has been created, you can use the Terraform plan command to make the changes to the RDS instance configurations, such as modifications of the instance, modifying the storage volume, or adding the tags. So these you can use to modify the instance after the creations. Use the Terraform apply command to apply the changes to the RDS instance. In case you want to destroy the RDS instance, when you are finished with the RDS instance, you can use the Terraform destroy command to delete the RDS instance. So these are the steps through which you can manage the life cycle of the RDS instance using their Terraform. This allows you to automate the creations, modifications, or the deletions of the RDS instance, which help you to ensure the consistency and reliability across the application infrastructure. So the question is, you want to deploy a Terraform configurations that creates an Amazon RDS database instance in a VPC with a specific subnet group, security group and parameter group. So this is the questions. If you refer my previous scenario based question where we are creating the Amazon RDS database, but in these questions there is a little bit twist. The twist is that they want me to use a specific subnet group in a particular VPC, and the security group also needs to be defined and the parameter group as well. If they ask you or they add a one statement in these questions, then that questions will be very easy for you. But these questions, with whatever the context they provided, it's a little bit twist. The twist is, let's make it simple. If I add one more statement here, that how can you ensure that the VPC subnet group, security groups and parameter groups are created before the RDS instance is created? Now the things will be easy, because you have one key point here, that before the RDS instance is created means before creating the RDS instance, the creations of VPC, subnet group, security groups, parameter group, all thing will exist before creating the RDS instance, because we are going to use it. So which parameter we are going to use for creation of the VPC? So you know that in Terraform you can use the depends on parameter to specify dependency between the resources. The depends on parameter allow you to specify that one resource depends on the others, which means that the Terraform will create the dependent resource only after the dependency has been created. You got my point? So here the steps you can take to ensure that the VPC, subnet groups, security groups and the parameter groups are created before the RDS instance. This is the twist. So one liner of text that I included from my side is missing, and the missing part makes it difficult to understand. So it's not like that you create the VPC first and then a specific subnet group. No, because VPC have the dependency on these things. Sorry, the RDS instance have the dependency on the VPC, subnet group, security groups, all these things. So we first need to create the VPC, subnet group, security groups and the parameter group. For that we need to use the appropriate Terraform resources to create the VPC, subnet group, security groups as well as the parameter groups. Okay, so if you look into the screens, I created a VPC first. We defined the local, whatever the local my VPC in my case. The CIDR block we defined it, which IP blocks to use for the whole VPC. Okay, then the resource is AWS _DB _subnet _groups, and this is my local name, my subnet group. Okay, and the name we can define accordingly. Subnet ID we can define it. Okay, and the resource group, my SG, we provided a name, and which VPC we use, the which we created before. Okay, so you can see that here the VPC ID is the VPC of the resources that we created, and the AWS _DB _parameter group, my DB group. So it's have the name and the family as well, so that we can, when we create the RDS instance, we can link all these things in the depends on. Okay, depends on parameters. Okay, so when we create the RDS instance here, so you can see when we create the RDS, we have the identifier. We already seen all these things in my previous scenario based questions. Here we define the group, but the main important thing is the depends on. Okay, where we defining the VPC, my VPC. Okay, from here we created, we linked it, and the subnet groups, it's created here. Okay, and the security groups we created here. So before creating the RDS, we created accordingly these items first. So this is the twist. In this way they make the questions complicated, and you have to understand it, because this question say that with VPC with a specific subnet security groups and the parameter that you have to use, so it must be created before. Okay, so by this example, the depends on parameter is used to specify the AWS underscore DB underscore instance, this one resource depend on the VPC, AWS VPC. Okay, AWS subnet groups, AWS security groups, and the parameter groups. Okay, this ensures that the Terraform will create these resources before creating the RDS instance. So these are the steps that you have to follow, so that you can ensure that the VPC, subnet group, security group, and parameter groups are created before the RDS instance is created, which ensures that your RDS instance is created with the correct configurations and all the dependencies are available before creating the RDS instance. So hope you. So you have a Terraform configurations that creates an EC2 instance with a public IP address, but you want to restrict access to the instance using a security groups. What steps you can take to accomplish this in a Terraform? So in Terraform, you can use a security groups. We already know that to restrict access to EC2 instance by allowing some traffic only from the specific IP address, or you can provide any range CIDR blocks. The steps you can take to restrict access to an EC2 instance using a security groups. So need to create a new security groups in your Terraform configurations and specify the inbound, that is called ingress, and outbound egress rules to restrict access to the EC2 instance. For example, you can allow inbound traffic only from your IP address. Okay, so in that case you can use either the static one, you can do the hard coded, like in this example we creating one resource type is the AWS security groups, and this is the local name mysg, and the name prefix we want to start with my underscore sg. The ingress, the inbound rules from port, this is for the SSH, okay, to port 22 protocol, and the CIDR blocks we are using as a variable. You can hard coded the IP address also, but this is not a good practice to do any kind of hard coding things. For the egress, we are not worried about, because this is the outbound traffic we are allowing for the all of the IPs. So in that case, we need to define the allow IP, type is string, and the default we are currently opening it for the all of the IP addresses. Okay, so ingress primary parameter is used to allow inbound traffic on port 22, that is used for the SSH only, from the IP address specified in the allowed IP variables. Okay, so we are using these variables. Okay, so in the variable.tf file we have different variables we defined, for one for the images, one for the instance type, and the egress parameter is used to allow outbound traffics to any destinations. To make your Terraform configuration more flexible, you can use the variables to specify the allow IP addresses and other parameters. You can define a variable for the allow IP address in your Terraform configuration like this. Okay, then it's time to associate the security groups to the EC2 instance. For this, we use the resource type as AWS underscore instance to create the EC2 instance, or if it is already created, then you need to define the VPC underscore security groups ID, and the security groups ID is my sg.id. Okay, so we already created it, and the CIDR block we defined from the variables. Okay, so associate the security groups with the EC2 instance and modify your Terraform configurations to associate the security groups with the EC2 instance. You can use the VPC security groups ID parameters to specify the security groups ID that we already discussed. Suppose you have a Terraform configurations that create an EC2 instance with a public IP. You can modify your configurations associated with the security groups with the instance. So this is mentioned here. Okay, so you can define here the subnet ID. All the things will come from the variables. Currently it's only concerned about how to allow the IP, but in the Terraform variables.terraform file we have the variable defined for the AMI ID also, instance type also, key name also, subnet ID also. Okay, so in this example the VPC security group ID parameter is used to associate the security groups with the instance EC2. You can then pass the allow IP parameter variable at the runtime also. So this is the hard coded thing again, but we are using the variable, so we can override it at the time of applying the changes. Suppose this is for all the traffics, all the IPs, but we want to use it for a particular IP. In that case we can use the var variables. So we can apply these configurations, the Terraform file configurations that we did using the Terraform apply -var and the allow IP. This is the variable that we are overriding. So default will not come into the picture, it will override with this particular IP. Okay, so in conclusion we can say that Terraform provides several options to restrict access to the EC2 instance using the security groups. So you can create a security groups and specify the inbound outbound rules to restrict access. Associate the security groups with the instance. Okay, so we can do the mapping that we created the EC2 instance, then we map the security groups ID for a particular with the particular security groups ID that we defined, and that security groups have ingress and egress, bonding and the configurations attached. Okay, so security groups with the EC2 instance and use the variables to make the Terraform configurations more flexible. So hope you liked my video. If you didn't subscribe my channel, please do subscribe it. This always motivates me. Thanks for watching this video. Thank you. Have a nice day.